Good evening, dear students. Yes, so we have completed in the previous session, we have completed the chapter D and F block elements. Right, so today we are going to start with the new topic that is chemical kinetics. Okay, we are going to study about chemical kinetics. So you might have studied about this topic, chemical kinetics. So what all things you have studied in this particular chapter or chemical kinetics? Yes. So you might have studied about rate, right? You might have studied about the rate. Yes, so you might have studied about rate. Yes, average rate. Okay. So you might have studied about average rate, then instantaneous rate, right? So what are the different factors which are affecting the rate of reaction, right? Then you might have studied about order of reaction, right? Molecularity, right? Then different orders, zero order reaction, first order reaction, right? Second order reaction, half-life, right? So these all things you might have studied in this particular chapter. Then the differences between order and molecularity of a reaction, right? Then a pseudo first order reaction. Okay. So these are the important things, okay, from this particular chapter. So chemical kinetics. Okay, so the from this particular chapter the derivations are very important, right? So derivations are very important. So zero order reaction, first order, half life. So the problems on half life. So yes, somebody has. Yes, Dhanush. Okay, so we'll be solving the numericals at the end. Okay, so this particular chapter, chemical kinetics, it is for 13 marks. Okay, so this particular chapter is for 13 marks. So the allotment of 13 marks will tell you by the end of the class. Okay, so first, so 1 mark at least the MCQs. So from this chapter, you'll get MCQs as well as the fill in the blanks. Okay. So from this chapter, you are going to get MCQs as well as the fill in the blanks. Okay, from this particular chapter. So we'll start without delaying much more. Okay, so we'll start with the so we'll start with the MCQs. Okay. Okay, so the first, I'll just zoom it. Okay, so I think you can see it now. The reaction A to B follows second order reaction kinetics if the rate of A is increased by 3 times. The rate of formation of B will be increased by 6 times, decreased by 6 times, decreased by 9 times, and increased by 9 times. So this is a question. The reaction A giving you B follows second order kinetics. If the concentration of A is increased by 3 times, then the rate of reaction of B will be, what will happen to the rate of reaction formation of B? Increase by 6 times, decrease by 6 times, decrease by 9 times, or increase by 9 times. Okay, Dhanush has answered it as A. Others? Yes. What about others? It will be Vinushre has also answered it as A. Okay. Others, try to answer. The reaction A giving you B follows second order kinetics. If the concentration of A is increased by 3 times, the rate of formation of B will be. So, see here. Okay, again, AK has also answered it as A. Okay, so let me tell you the answer now. So since, okay, for the second order kinetics, so when you are talking about second order kinetics, okay, so how is the rate given for second order kinetics? For A and for A giving you B, okay, so if you're considering A giving you B, okay, that is for a second order kinetics of the reaction A giving you the product B, okay. Then we have the rate, okay, rate is given as small k is equals to A square, okay. So where you're, if you're doubling the concentration of A by 2 times, okay, here they have doubled, increased it by 3 times. Okay, they have increased the concentration by 3 times. Then rate of the reaction also increases. What will happen to rate of reaction? Rate of reaction increases. Okay. So by a factor. So what will happen? So now A is what? A is 3. So 3 square is what? 3 square is 9. Okay. So since rate of conversion of A is equal to rate of formation of B. So it will be 9 times. Okay. It will be increased by 9 times. So it is option number D. Is it clear? It is option number D. Is it clear, students? Is it clear? Yes. Okay, good. Fine. Fine. Okay. So like this, you have to apply it. Okay. Moving for the next question. Molecularity of a reaction 2HI giving you H2 plus I2 is A1, 2, B2, C0 and D3. AK has answered it as 2. Others? Molecularity of the reaction 2HI giving you H2 plus I2. Yes, try answering. Okay. See here, how many molecules are involved here? Molecularity, yes. What do you mean by molecularity of a reaction? Molecularity reaction means what? The number of reacting species. Okay. The number of reacting species which collide simultaneously to bring about a reaction is called as molecularity of a reaction. So molecularity is always a whole number. Okay. And it cannot be fraction or it cannot be zero. Okay. And so here the number of molecules. Yes. So the number of molecules involved in the reactions are how many? Two molecules are involved. Okay. So the number of molecules involved are two. So the answer is B, 2. The number of molecules, here two molecules are involved. So the molecularity will be, it is 2. So the answer, yes, 2 is correct. B, option number B. Okay. Moving forward, next question. All natural and artificial radioactive decay of unstable nuclei take place by A, zero order kinetics, B, second order kinetics, C, first order kinetics, and D, third order kinetics. Yes, all natural and artificial radioactive. decay of unstable nuclei takes place by zero order kinetics, B second order, first order, or third order? Dhanush has answered it as C. Usha has answered it as B. Okay. Others? Vinushri has answered it as C. AK has answered it as B. Okay. So all natural and artificial radioactive decay of unstable nuclei, okay, it takes place by second order kinetics. Okay, it takes place by second order kinetics. So it is option number B. Okay, it is option number B. Next question. In a reaction 2A plus B, in a reaction 2A plus B giving you A to B, the reactant A will disappear at A, half the rate that B will decrease, B, the same rate that B will decrease, C, twice the rate that B will decrease, and D, the same rate A to B will form. Usha has answered it as C. Others? Dhanush has also answered it as C. Okay, Vinushri has also answered it as C. Yes, C is the correct answer. Okay, twice the rate that B will decrease. Okay, so when you are referring the rate law of reaction, okay, from experimental data, so it can be predicted. So the order of reaction can be predicted. So rate of the reaction, chemical reaction is a change in concentration over the change in time. So how it is given as? It is given as, so the rate of disappearance of a reactant is given as minus delta, okay, then the reactant in the concentrations, okay, in the bracket, and by delta T. So this is given in the form of change in, that is change in concentration over change in time. Okay. So your negative sign, what does negative sign? It tells you that rate of disappearance of the reactant. So this negative signs, it represents, or it tells you, it describes about the rate of disappearance of the reactants. Okay, and how the formation of products is given, it is given as delta, okay, products, delta into products, okay, divided by change in time. Okay, so okay, it states that the products are formed. So the rate is given for products as like this. Okay. So when we are discussing, okay, so the answer is, so when you are going through this equation, okay, so the rate of disappearance of the reactant A will be twice the rate of disappearance of reactant B. Okay, so reactant A will disappear. Okay, reactant A will disappear at the twice the rate of B. Okay, and what will happen to B? The B will decrease. The rate of B will decrease. Okay, so option number C is the right answer. Okay, moving for the next question. For a first order reaction, the plot of ln of R versus T gives a straight line with slope equal to. AK has answered it as A, Dhanush has answered it as D. Okay. So when you are plotting the okay, the plot of ln of R versus T. It is giving you a straight line with a slope which is equal to, okay, for first order kinetics. For first order. Slope is equal to, okay, yes, Dhanush, Vedvati, yes, the answer is correct. It is minus k. Okay, it is equal to minus k. So option number D. So how is the plot? Okay, the plot is like this. That is ln of r, okay, versus t. So it is this. Okay, so this is a first order kinetic graph. This is a graph, okay, of first order kinetic, and the slope is minus k. Okay, the slope will be equal to minus k. And what is the intercept? What is the intercept? Intercept is ln of r naught. Okay, the intercept is ln of r naught. Okay, so these are the things. Can you tell me what is the unit of this here, k here? What is the unit of k? What is the rate here? Rate is given for first order kinetics. Can anyone tell me what is the unit of k or yes, Dhanush, yes, it is correct. Per second. Good. Yes, Dhanush has answered it right. It is per second. Good. Yes, Sushmita has also answered it right. Minute per minute, AK, it is not the lowest this, okay, in time. So when you are considering the time, we have to take the smallest unit. Second, okay, second is the smallest this. A minute, no. It is per second. Yes, Sushmita has also answered it right. Good. Okay, fine. So moving forward, next question. A large increase in the rate of reaction for a rise in temperature is due to a large increase in the rate of reaction for a rise in temperature is due to A, increase in the number of collision, B, the increase in the number of activated molecules, C, the shortening of mean free path, and D, the lowering of activation energy. Okay, Dhanush has answered it as A. Others, the large increase in the rate of reaction for a rise in temperature is due to, Shushmita has answered it as B. Usha has answered it as B, activated molecules. So as you increase the temperature, okay, as the temperature is increased, okay, the rate of reaction also increases. So what will happen? Vedvati has answered it as D. Okay. Yes. So the answer is B. Okay. So the large increase in the rate of reaction for a rise in temperature, it is due to the increase in the number of activated molecules. So as the number of activated molecule increases, okay, so there will be okay, there will be what you say rise the rate of reaction. Okay, there will be increase in rate of reaction. Okay, next question, a direct question. Arrhenius equation will give the value of activation energy. Okay, so these are the four options. Go through. Okay. AK, Shushmita, Dhanush have answered it as A. Yes, A is the correct answer. Okay. K is equals to AE minus A by RT. So this is the correct answer. Yes. Usha, Vedvati, yes, have answered it right. Good. Okay. So this is a direct question. Next question. The rate constant of a reaction depends on. So on what does the rate constant depend on? The rate constant of a reaction depends upon A, temperature of the reaction, B, extent of the reaction, C, initial concentration of the reactants, and D, the time of completion of the reaction. Yes, Shushmita, Usha has answered it as C. Initial concentration of the reactants. Rate of the reaction depends on what? Rate of the reaction. Yes. Yes, rate of the reaction. Okay, students, it depends on only the temperature. Okay, it depends only on the temperature of the reaction. Okay, and not, it is not affected by concentration. It is not affected by concentration. It depends only on the temperature. Okay, it depends on only on temperature of the reaction. Okay. They have asked you rate constant, okay, not reaction rate. So rate constant of a reaction, it depends on the temperature, okay, and not on the initial concentration. So option number A is the right answer. Next one, the unit of the rate constant for zero order reaction is. Yes. Okay, Usha, Dhanush, AK, Shushmita, Vedvati have answered it as A. Yes, A is the correct answer. It is mole per liter per second. Okay, mole per liter per second. Yes, it is a right answer. So mole per liter per second is the correct answer. Okay, next question. A biomolecular reaction can behave as first order reaction. Yes, a biomolecular reaction can behave as first order reaction when both reactants have same concentration, when one of the reactants is in large excess, C, when the reaction is in equilibrium, and D, when the activation energy of the reaction is less. Okay. AK has answered it as D. Dhanush has answered it as A. Vedvati has also answered it as A. Yes. A biomolecular reaction can behave as first order. When it can behave as first order, for okay, biomolecular is nothing but your pseudo first order reaction. Okay, so this tells you about biomolecular system. So how, when it acts as first order, when one of the what is that, one of the reactant, when it is taken in large excess. Okay, when it is taken in large excess, for example, if I take acid hydrolysis of methyl acetate. Okay, if I take acid hydrolysis of methyl acetate, so what will it will be CH3 COO CH3, okay, plus water in the presence of dilute HCl. In the presence of dilute HCl gives you what? Acetic acid plus ethanol, methanol. Okay, acetic acid and methanol. So the rate is given as what? Rate is equals to K into CH3COO, CH3COO, CH3. Okay, the rate is 1 and your water concentration, okay, water concentration is 0. So order, so you can see here one of the reactant is taken in excess. Okay, so it will be what? 1 plus 0, it is 1. So the one of the reactant should be taken in excess. One of the reactant should be taken in excess. Then only the biomolecular reaction behave as a first order reaction. Next question. The role of catalyst is to change A, Gibbs energy of a reaction, B, enthalpy of a reaction, C, activation energy of a reaction, and D, equilibrium constant. Yes, what is the role of catalyst, students? What is the role of catalyst? What is the role of catalyst? The role of catalyst is to change. Dhanush has answered it as A. Okay. Others? What about others? What about others? Okay. Mm. Vedvati has answered it as D. Usha has answered it as A. The role of catalyst. Do you know what do you mean by catalyst? Yes. What is a catalyst? Catalyst, what it does, it increases the rate of reaction. Okay. It does not alter the path or anything. It just increases the rate of reaction. So here, what is the role of catalyst when you are doing the when we are studying the order of reaction? So here is nothing but it activates the energy of reaction. Okay, it activates the energy of reaction. Yes, AK has answered it right. It is C. Okay, so the role of the catalyst is to change the activation energy of a reaction. So catalyst, it does not changes the Gibbs energy of a reaction. Okay, it does not changes the enthalpy of a reaction, or it does not changes the equilibrium constant. So what is the role? It is just to change the activation energy of the reaction. Okay, fine. Next question. The rate law The rate law equation for the reaction A plus 2B giving you C plus D is rate is equals to K into concentration of A. The order with respect to B is. Yes, students? The rate law equation for the reaction A plus 2B giving you C plus D is R is equals to K into concentration of A. The order with respect to B is. Okay. Dhanush has answered it as C. Usha has answered it as A. Okay. So yes, the answer is A. Okay, answer is A, 0. Okay, the answer is A. That is 0. So the rate law equation for the reaction A plus 2B giving you C plus D. The rate R is equals to a rate is given as K into concentration of A. The order of reaction with respect to B is 0. So it is 0, 0 order reaction. Okay. Next question. The rate constant of a reaction is 2.3 into 10 raised to 5. The order of reaction is. What is the order of reaction? The rate constant is given. What is the order of reaction, students? Based on the rate constant, you can tell the order also. What is the order of reaction? It is yes. And Dhanush has answered it as B. Others? Yes, Usha has also answered it right. Yes, it is 2. Okay, you can see the rate constant is 2.3. Rate constant is 2.23. The order of reaction is 2. Okay. Next, inversion of cane sugar and hydrolysis of ester are example of. Easy question. Inversion of cane sugar and hydrolysis of esters are example of. Dhanush has answered it as D. A zero order, B second order, C first order, and D pseudo order. Usha has also answered it as D. Others, what is the answer? Inversion of cane sugar and hydrolysis of esters are example of it is, yes, it is an example of pseudo first order reaction. Okay, it is an example of pseudo first order reaction. Next question. Molecularity and order of an elementary reaction are same, different, zero, none of this. Molecularity and order of elementary reaction are molecularity and order of a elementary reaction are Dhanush has answered it as A. Vedvati has answered it as B. Usha has answered it as A. Yes, molecularity and order of reaction are same, different, zero, or none of this. It is so remember that the answer is same. Okay. So order and molecularity of a reaction will be same. When it will be same? If the reaction is elementary. Okay, if the reaction, so order of an elementary reaction. So whenever the order and molecularity of a reaction, it will be same when the reaction is elementary. Okay, so the answer is same. Last one, the substances which reduces the rate of reaction are A. Catalyst, B. Reactant, C. Moderators, and D. Inhibitors. The substances which reduces the rate of reaction are Dhanush has answered it as C. Okay. Usha has answered it as D. Others? So the answer is D. Answer is D. So inhibitors. Okay. So a reaction inhibitor is nothing but it is a substance which decreases the rate or okay, it decreases the rate or it prevents any chemical reaction. Okay. And other the catalyst. Okay. What is the role of catalyst? The catalyst, it increases the rate of reaction. Okay, and inhibitors, they will decrease the rate of reaction. Okay, so these are the questions. Okay, these are the MCQs. Next, we are going to see the fill in the blanks. Okay, so next are the fill in the blanks. So fill in the blanks by choosing the appropriate uh, answer. Okay, next, so first question is, for a chemical reaction with the rise in temperature by 100, the dash is nearly doubled. For a chemical reaction with rise in temperature by 100, the dash is nearly doubled. It is not by 100, it is by 10 degree. Okay, small mistake, my mistake. Just a second. Okay, it is 10 degree. Okay, this is 10 degree. So for a reaction, chemical reaction with the rise in temperature by 10 degree, the dash is nearly doubled. What is nearly doubled? So when you have a chemical reaction and if there is a rise in temperature by 10 degree, the what is double? It is rate constant. Okay. The rate constant is nearly doubled. Okay. So at suppose temperature plus 10 degree, what will happen? The fraction of molecules will have energy which is equal to or greater than the activation energy. And what happens? It gets doubled. Okay, it gets doubled. Fine. Next one. In zero order reaction, the rate is independent of. Yes, in zero order reaction, the rate is independent of. The rate is independent of. Yes, it is independent of concentration. Okay. The in zero order reaction, when you are seeing the rate, yes, correct. The Nusha has answered it right. It is independent of rate of concentration. Okay. So the rate is independent of concentration. Next question. Half-life period. Half-life period of a first order reaction is independent of. Initial concentration. Okay, Vedvati has answered initial concentration. Yes, initial concentration of reactant. Okay, initial concentration of reactant. Okay. Next question. In a complex reaction, the rate of reaction depends on. In a complex reaction, the rate of reaction depends on. In a complex reaction, the rate of reaction depends on. Yes, students? Whenever there is a complex reaction, the rate of reaction will be depending on what? It will be depending on the slowest step. It will depend on the slowest step. Okay, it will depend on the slowest step. Okay. Next question. Thermal decomposition of HI in on gold surface follows dash order. Thermal decomposition of hydrogen iodide on the gold surface, it follows which order kinetics? Yes, it follows which order kinetics, students? It follows which order kinetics? Zero order. Yes. It follows zero order kinetics. Good. It follows zero order kinetics. Fine. Moving forward, next question. The number of collisions per second per unit volume of the reaction mixture is known as. The number of collisions per second per unit volume of the reaction mixture is known as. Yes, Vedvati has answered it right. It is collision frequency. Yes. So collision frequency. Good. Okay, so collision frequency, it is nothing but the number of collisions per second per unit volume of the reaction mixture. Okay, it is given by capital Z. It is given by capital Z. Next question, the reaction in which only one reacting species is involved are called. Yes, The reaction in which only one reacting species is involved are called. What they are called? They are called as unimolecular reaction. What they are called as unimolecular reaction. Okay, only one species, one reacting species is involved. Then they are called as what? Unimolecular reaction. Next question. The rate of reaction dash with the passage of time as the concentration of reactant decreases. The rate of reaction, okay, dash with the passage of time as the concentration of reactant decreases. Yes, the rate of reaction. What happens to rate of reaction with the time as the concentration of reactant decreases? The rate of reaction also decreases. Okay, the rate of reaction also decreases. So as the time is passed, okay, as the time is passed, as the time is passed, okay, what will happen to concentration? Concentration decreases. Okay, the rate of reaction also decreases. Fine. Next question. The sum of powers of the concentration of the reactants in the rate law expression is called dash of that reaction, chemical reaction. The sum of powers of concentration of the reactant in the rate law expression is called dash of that chemical reaction. It is called as order. Okay, it is called as what? Yes, order. Yes, Vedvati has answered it right. Yes, Danush has also answered it right. Order. Okay, it is given as order. Fine. Next question. The half-life period for a zero-order reaction is inversely proportional to the half-life period for a zero-order reaction is inversely proportional to. Yes, it is inversely proportional to rate constant. Yes, it is correct. It is inversely proportional to rate constant. Good. Okay, it is proportional to rate constant. Fine. Next question. In terms of collision theory, in terms of collision theory of kinetics, the rate of a chemical reaction is proportional to the dash per second. In terms of collision theory of kinetics, the rate of chemical reaction is proportional to the dash per second. Proportional to the collisions per second. Okay, it is proportional to collisions per second. Fine. In the first order reaction, the concentration of the reaction decreases dash with time. In a first order reaction, the concentration of a reaction decreases. Yes. Yes, increases. In the first order reaction, the concentration of the reaction decreases with, I think there is some, okay. We'll switch to the next question. Okay. So there is some missing words are missing. The rate of reaction is independent of the concentration of the reactants. Then the order is. So what is the order? The rate of reaction is independent of the concentration of reactants. Then order is 0. Yes, it is a 0 order reaction. Good. Yes, Dhanush and Vedvati have answered. No, Dhanush has answered. Okay, good. Okay. Next, expression of rate at particular instant of time is called. Expression of rate at particular instant of time is called. It is called as instantaneous rate of reaction. What it is called as? It is called as instantaneous rate of reaction. Okay, expression of rate at a particular instant of time, it is given by instantaneous rate of reaction. Next one, half-life of dash order reaction independent of initial concentration of reactants. Yes, half-life of dash order reaction independent of initial concentration of reactants. Half-life of dash order reaction independent of initial concentration of reactants. Half-life of, it is first order. Okay, half-life of first order reaction is independent of initial concentration of reactants. Last question. For a chemical reaction with rise in temperature by 10 degree, the rate constant is. For a chemical reaction with rise in temperature by 10 degree, the rate constant is. The first question only, they have asked it again. Okay, it is doubled. It is doubled. Okay, it is doubled. The answer is doubled. Fine. Okay, so these are the questions. Okay, just 2 minutes. I'll tell you the. Okay, so for your chemical kinetics, okay, see here, for your chemical kinetics, the marks allotted is 13 marks. Okay, so the marks allotted is 13 marks. Total marks allotted is 13 marks. Okay, so 1 mark you will be getting two, two questions. Okay, 1 mark, two questions. So one fill in the blank and one MCQs from this chemical kinetics topic. Okay, then 3 marks you will be getting one question. Okay, 3 mark, one question that is a theory based question. Okay, 3 marks theory based question, and okay, 2 mark one question. Okay, and again 3 marks two questions, that is numerical problem. So you'll be getting numerical problems on this particular. Okay, so you are getting how many now? Yes. Yes, so we'll be solving the numericals at the end. Okay, so you are so we have solved now MCQs. We have seen the fill in the blanks. So next we are going to see the 2 marks, 3 marks theory, and 3 marks numerical questions. Okay, so you are going to get so totally 13 marks. So 3 marks, three questions. So out of three, two will be numerical, one will be theory based, and 2 marks one question, and 1 mark two question. Okay, so this is the mark distribution. Is it clear? Okay, any doubts? So these are the things. Okay, so we cannot go deeply in all the concepts. Okay, so we are just going to what touch the main concept. So next class we are going to start with 2 marks and 3 marks. So there we are going to discuss the important derivation. Okay, important numerical problems. Okay, how we are going to solve them. Okay. So any doubts in today's session, students? Okay, fine. So, fine. So, in the next class, we are going to discuss the 2 marks, 3 marks questions. Okay, fine. So, please go through the things which have been told. Okay, so that will help you. Yes. Okay, so I shall end the session here. So, we'll be meeting in the next class. Thank you.